I'm Walker Hale from the Baylor College of Medicine. Today I'll be talking about PyYAML, ElementTree, and then giving a little demonstration of an application in Liquibase. So the big one to start talking about is PyYAML. Well, between that and ElementTree, this will be, for most of you, the least familiar. So YAML. YAML is a language for serializing information. It is in a similar space as JSON. It's not quite the same space as XML, because JSON and XML are tackling somewhat different things. But there is a very close relationship between YAML and JSON. So you could just search for YAML on Google. Oops, sorry. And you'll find out some about it. There's the official YAML site that you can go to. And it's going to show you some documentation. And the thing about YAML, let's get down to some of this, is that it is optimized for the experience of humans reading and writing the data. So unlike XML or even JSON, YAML is trying to make it as human-friendly as possible while still being machine parsable. So in YAML, a list looks like a list. And some kind of dictionary or map looks like a map. And you can mix them. So if you were to go to the official YAML site, you'll see that there is one main Python library for working with YAML, which is called PyYAML. If you are using either nThought's Canopy or Continuum Analytics Anaconda, you've already got YAML. It's already built in. Otherwise, it's the standard type of install process. It's available on the cheese shop. I'm sorry, the Python package index. All right, JSON. YAML has a number of different styles for encoding the information. It can do it in that sort of longer format that I showed you, but it can also do it using square brackets and curly braces, and it starts looking a lot like JSON. So much so that the YAML developers realize that we are so close to JSON. We just need to tweak a few things, and YAML would be a strict superset of JSON. And as of YAML 1.2, that became reality. YAML 1.2 is a strict superset of JSON. So that means that any legal JSON is also legal YAML, not the other way around. However, the Python driver, the Python library to support YAML is only 1.1, which is not quite a strict superset of JSON. Most legal JSON is legal YAML 1.1, but you probably find some edge cases. And in any event, the standard library built into Python has a perfectly good JSON module. So if you need to read or write JSON, use that. But if you're targeting the human-friendly, go for the YAML. So let's just crank through a couple of demos here. All right, so this is like lifted right off that web page. Here is a document that is obviously a list. And lo and behold, I get a Python list. If I want to dump it back out, so given data, if I'm starting with a Python list and I wanted to turn that into a YAML string, I can do that. And you'll notice that YAML defaulted to this inline style that's very compact, but not as human-friendly. If I've got a long list, that's not going to be as nice to read. It'll start wrapping around the lines. I've got to scan across and look for the commas. Not as friendly. That's OK. You can turn that off. And there you go. We're back to pretty close to the original list. Here's a different document. Let's dump it. We get, of course, a Python dictionary. Notice that YAML detected that numbers are numbers. We didn't have to tell YAML that's a number. YAML just goes, oh, that must be a number. If for some reason you had a string that looked like a number but wasn't a number, then you would need to use quotes. You need to put quotes around that string. If you want to say 123 the string as opposed to 123 the number, then you're going to have to put quotes around the 123. But if there's anything else in that data area, like 33rd Street, well, obviously that's not a number, that's a string. YAML will notice that and do the right thing. We can dump it back out. And here you see I'm dumping it two different ways, both the flow style and without the flow style. You can mix and match maps and lists. So here you see I've got a dictionary is the outer container, and the values of the dictionary are lists. And I get back exactly what you would expect. And if I dump it back out the other way, I get two different forms. Notice that the commas, by the way, comments get lost. There's nothing you can do about that because, after all, they were just comments. Okay. So here's the other way around. Here is a list of dictionaries, or if you prefer, a list of maps. It's doing exactly what you'd expect. Now, notice how you've got this, it doesn't quite look right. It's technically, mechanically correct that this is saying here's an item in the list, here's the value of that list item, and here's the next item in the list and the value. But I think this looks prettier. Or maybe this with a blank line right there. And that's an equivalent way of expressing the same information. Notice data 5 equals data 4. All right, here is sort of the tour de force. The thing about YAML, it's a superset of JSON, and just like JSON, that means that you can represent pretty much any reasonable data scenario you can come up with. If you support a dictionary, a list, string, a number, and some concept of null or none, you've pretty much covered all the bases. You can represent any information you'd want to. Yeah, maybe dates have to be turned into strings. Maybe pictures or image data have to be encoded with some kind of binary to text encoding. But at that point, your bases for most things are covered. So here is an example I ripped off of, I think it was Wikipedia. And you can just look at this, and you know what this document is talking about. There's no difficulty in reading this. We understand this is a fictitious receipt to Dorothy in the land of Oz to get the stuff she's going to need to defeat the witch and have her happy ending. The only thing that's even slightly odd is this bit right here. This is saying that the ship to address is the same as the bill to address. And that's one area, something YAML can do that JSON can't do. This is one of the classic problems with serialization, is if you have the same object twice in some data structure, and you want to represent that as the same object twice, rather than two copies of information that happen to be identical. YAML will let you represent that cleanly. It's not the most human-readable thing in the world, but realistically, for a concept like that, this is probably about the best we can do. The other things I would point out is that notice what's going on here and what's going on there. Those are directives to YAML about how the text is going to be represented. This one is saying, I want the text to be represented as is, an equivalent of like a pre-tag in HTML. The only thing that's going to be modified about this is that the leading white space will be stripped away, because that was representing nesting, but the line separator between here and there will be preserved. This, on the other hand, is saying we just broke up the lines to make them look nice in the YAML document, but those line breaks are not to be taken literally. They should be replaced by spaces. similar to the p tag in HTML. So this one will wrap, the other one will not wrap. Okay, did I load that? No, I haven't. Okay, hit that, load it, and look, exactly what we expected. Notice that ship2 and bill2 are filled in. We can inspect the value of the ship2, that street element, and see that it did wrap correctly. We can, or did not wrap, we can look at special delivery, and it did get all concatenated together into one long thing. Now let's see, are ship2 and bill2 the same object? And yes, they are. So they're not just equivalent, they are the same object, references to the same data. If I dump it out, I get back nearly what I put in. You see subtle differences in the amount of indentation. The ordering is lost, of course, because dictionaries are unordered. So the data was dumped out in alphabetical order, not the original order. There was no attempt to preserve that. It did recognize that ship2 and bill2 were the same object, so that's all good. But the street kind of looked, it's not as nice as what the original thing looked like. But that's the YAML representation of it. Was the data actually preserved? Are we going to round trip correctly? And the answer is, if I take that document, that new document from the data, and load it back in, are they the same? Yes, they are. So this is an amazingly powerful capability, because this lets me write config files or other types of non-Python artifacts in a very nice, clean way. This is an alternative, in many cases, to writing your own domain-specific language. Just write it in YAML, maybe have some magic keys saying, here's a verb, here's another verb, string them together in what amounts to a list. You can start doing amazing things, writing your own kind of domain language on top of YAML, and not have to then bother with your own parser. And the resulting documents will be beautiful to humans, readable by humans, and that's a very, very important thing. Okay, so that's the story with YAML. Learn more. You can just follow the links. The other part of this story is ElementTree. So where I work, we have to deal with XML, both large and small. ElementTree fits. Oh, do you have a question? You're asking what is the performance of YAML? I do not know. There is a libyaml written in C. And so if you get everything wired together, you'll be using the C version, and you should get some performance. Where I work, though, I'm not in a position to evaluate performance because our challenge is not scaling up or achieving high performance, but scaling down, conserving the human resources, not the silicon resources. So where I work, 200 lines of code is expensive, and CPU is relatively cheap. So sorry, I don't know the answer to that. So you just have to try it out. All right. So, and that's a similar issue I'm going to raise with ElementTree. So where I work, we deal with large XML files and we deal with small XML files. Large XML files is we could run a query against an external web service, and the next thing you know, you've got 200 megabytes of XML in one file. In a situation like that, where we're only interested in a few pieces here and there, I ditch Python, I go straight to XSLT, and I do what I need to do in something that's high performance like XSLT. And I can digest 200 megabytes of XML into, say, a tab-delimited file in seconds, or less than a second sometimes. That's a couple seconds. But there's this, so that's one part of our problem space, is large amounts of data that's very regular, and we just want to digest the bits that we care. The other part of our problem space is small amounts of data, of XML data, that we need to process, and we don't want to do it by hand. XSLT is not the right fit. DOM is not the right fit. It's just too tedious. You know, an XML DOM gets into all sorts of tedious elements about every bit of white space becomes its own thing. And it's just tedious to program against. ElementTree hits this sweet spot of going after XML in the small scale. It's not high performance. You're slurping the whole thing into memory. So if you feed it a big XML document, you're just going to blow memory. And it's not going to be particularly fast, but again, it's going to give you a very nice experience for the programmer. So if you are trying to tackle small problems and conserve your human resources, you know, you don't want to blow thousands of dollars on human resources for a small problem, then ElementTree hits that spot. And I'll show you concrete, practical examples where you really, really want that. You know, what ElementTree is not competing against DOM or pull DOM for the high performance. ElementTree is competing with hand patching. ElementTree will solve your hand patching problems of XML or your hand crafting problems of XML, where DOM would be much more tedious, and other tools would also be tedious. All right, so let's do our little demo. Here is, so there are some resources. I will point out ElementTree was originally written by a guy, I think his name was Lund, and there's the original website. Like many libraries in the Python standard library, it started outside of Python. Eventually, a version of it got pulled in and has been carried forward ever since. All right, so here is a sample XML document. This is ripped straight out of the Python library documentation. So there I am. I'm just going to pull this in. How you parse XML depends on whether you're parsing a file or you're parsing a string. And the other thing to be aware of is in ElementTree, there are two kinds of critical objects. There's an element object and a tree object. And this is keeping with what was really going on with XML, is that in XML, you really did have these two separate concepts. There's the tree, the overall document itself, an element, which could be a piece of a document. And every tree will have a root element, but a tree can only have one topmost element. That's sort of a limitation of XML. So the ElementTree library respects that. But watch out, because that means if you're reading a file, you will get a tree object, and you'll then need to extract the root element from that tree object. On the other hand, if you're parsing some text, like say you've called a web service, you know, some RESTful web service, and here's an XML string, and it never was a file, you got the root element. And so if you need a tree and you've got an element, you'll need to convert the element to a tree by just calling the constructor for the tree and passing that element in to be the root element of your new tree. But watch it. You know, there are these two contexts, just as there are in XML. You know, that's like one of the differences between XML and Lisp is, you know, it's not a context-free grammar. I mean, you can't just take two things that are legal XML, concatenate them, and have a legal XML result. Okay, so there I've parsed it. And of course, I just get this opaque object. I can say list your children. And so there we go. GetChildren is a method that returns a list of the children objects. But every element in ElementTree is also iterable. So if I can throw it in a for loop and not bother with GetChildren. So I could have gone for, and there we go right there, for child en route. Just throw it right in, works just fine. Every element has in ElementTree, has 4 key properties that you care about. There is the tag property. That's the actual text in your opening and closing tag. There's the attrib, which is a dictionary of the attributes. There is text, which is the body of the text that would be inside the element. And finally, there's something called tail, which is generally, it's also text, is used to represent any white space that might come after the element if you were doing some kind of pretty printing or indentation. Tail gets used. Now notice that model is a simplification of the model of actual XML. In real XML, if you were representing that in DOM, you've got text intermixed with other elements. There are these 2 kinds of nodes. There's text nodes, there's element nodes, there's more. And those are separate things. So back to our document here. DOM would see that between this element here and this element here, there's another piece, another object, which would be that piece of text. And this is also a piece of text. And so a country could have multiple pieces of text inside it, interspersed with XML elements. And DOM would faithfully represent that. Now, normally, when and if you're doing like web documents, XHTML, that all makes sense because you will be interspersing meaningful text with other tags. And that makes perfect sense. But if you're a programmer using XML to represent data, that's just tedious noise. And so you could still represent an XHTML document using ElementTree, but that means that the tail of your elements would start containing text other than white space. You'd have meaningful text in the tails of your elements. And that's probably not what you want. But for this kind of thing, this is obviously not intended to be rendered as a normal HTML or XHTML document. This is a serialization of data. And so ElementTree is a good fit. Because then we're just saying that every element has its tag, its attributes, and possibly embedded text. And the tail element is only used for pretty printing, or if you want your XML to be indented. Okay. So all the normal XPath, well, I can't say all, but the normal XPathy stuff works. So there I am pulling the gross domestic products for these various countries out. And that's how you're going to get data out. And here I am patching. Let's take every one of those GD, PPC, and double them. There, I've patched it. Now let's remove any countries where the rank is greater than 50. So uninteresting countries. Done. So that means, let's back to our original document. This should now be 400,000, this should be 200,000, and this guy should just be gone. Sorry. Yep. You want to add an element? There you go. In addition to et.toString, there's also a .dump method, and that just dumps to standard output. It's really only useful for debugging, or if for some reason your script was really using standard output as its machinery for delivering results. So that's just giving you the same thing, except now you see the new element I just added. Let's add some text to this element. So there's my bah humbug. Now, order of attributes. Just like with YAML, ElementTree has a problem. You've got a dictionary of information, and there might be a human sensible order to that dictionary, but it's a dictionary, and a dictionary is unordered. So just like YAML, when ElementTree is dumping or converting to text, its only option is to order the attributes. Well, it has two choices. Just order them pseudo-randomly or sort them alphabetically. It sorts them alphabetically. And so if you're writing test cases against some code that you've written using ElementTree or even using DOM, you really need to be aware of that, that your expected results should have the attributes in alphabetical order, because that's what any sensible library is going to do. And if you have your attributes in some other order that makes sense to you as a human, you'll start getting spurious test failures that aren't semantically meaningful, because the order of elements inside an XML tag has no meaning. So this is how you can convert an element to a tree, and that lets you do some things like call a write method. This is how you pretty print. So notice that we lost some indentation over here. You know, that dummy element just kind of got slammed in there, you know, not in a particularly nice way. The standard library doesn't fix that. And it's entirely up to you to either fix it or not worry about it or pass that on to some third-party tool like xml.lint. But if you go to so the resources I'm providing here, the guy who originally wrote the library provided some code for pretty printing. And there it is. It just does straightforward calculation and inserts new lines and spaces into the tails of your elements to do the right thing. And so now if I write it out, there's the proper pretty printing. So that's my machinery. I've got ElementTree, which by itself will let me generate XML or modify existing XML. I've got YAML, which lets me avoid XML as long as possible. So let's see what we can do with those two bits of technology. So where I work, we deal with something called CG Hub, the Cancer Genomics Hub, and something called SRA, the Short Read Archive. And SRA defines XML schema for certain kinds of things. This is a piece of analysis that was done. This corresponds roughly to a physical experiment. And this is sort of the connection between a physical experiment and some resulting data. Those are like the three currency pieces of XML that we need to deliver as metadata when we're producing our currency data file, which is a .bam file. These are these huge files that contain next-gen sequence data. The thing is that SRA schema has undergone revisions. And sometimes we are called upon to take XML in one version of a schema and update it to a new version of a schema. And for reasons that we don't really need to go into here, the best way to do that is rather than going back to a database and trying to regenerate it, because that's actually a much harder problem, is to take what we've got and patch it. And once you've crossed that line saying, okay, we're now in the business of patching XMLs, that gives you flexibility to start injecting new bits of information that maybe aren't even in your database. Maybe that new piece of information is in some third-party external web service, which in this case was exactly part of our problem. We would need to look up a piece of information in the XML, pass that to a RESTful web service, get the result, and use that as a replacement in the XML. So here's our CG Hub patcher. And here we are pulling in ElementTree, listing the XML files we're going to process. Here is the URL that we're going to have to go to do a certain lookup. I'm using argparse, so you don't need to really care about that. And here I am, 3 top methods. I'm going to read the XMLs, patch them, write them back out. So read the XMLs, that's just going to give me a dictionary where the key is a top-level concept like experiment, and the value will be the corresponding ElementTree tree. Patching is just calling a series of functions, each of which knows how to do one kind of patch. And when we're done, writing will, well, that's going to be pretty straightforward. We just indent. Actually, in this case, because our patching was so light, we didn't need to re-indent. We just write it straight out. So let's look at the detail of a single patch. Let's see. Here's a nice simple one. OK. Oh, yeah, fetch the UUID. So we won't go into calling the web service, but we will go into using it. OK, so patch the analysis. Let's focus on this bit right here. So given the analysis object, which was being passed into this patcher, the analysis object is an element tree. We're going to do a find. There's my XPath to find it. We're going to get our target element. We set one of the attributes. We get another attribute out of the element, the ref name. We convert that from a barcode to a UUID, set it back, and there you go. And then for reference, because elsewhere we're going to need this, we return those values. But this is not part of the patching of that element. That's just being used by other patchers later. So that could be stored in local variables so that other patchers could take advantage of that. So the actual work of patching a piece of XML was this bit right here. You find the element, you read some values out, you write some values back in, you're done. The element was patched in place, and it's still part of this larger object graph that is that tree. And sometimes we need to look up from some external thing. So there's this thing called the BAM header, which had stuff, and we had to do a lookup in there. So we were pulling from the original XML. We were pulling from an external web service. We were pulling from this extra text file and doing all these patches. And then when we're done in memory, we have these 3 element trees that are the patched up versions of what we just read from disk. And so now we just write them back to disk. Which is pretty straightforward. We create an output directory and just write them out by using the .write method, which is a method on a tree. And then we explicitly write out the XML declaration because ElementTree doesn't do that for us. And there you go. That is how you can take older XML and turn it into newer XML. There are some things that ElementTree does not do well, such as working with namespaces. That's kind of problematic. As you just saw, we had to write our own directive out. But for the core stuff about working with the object graph that resulted from parsing with XML and doing stuff to it, this is working great. And this is one of the things that I really appreciate Python for, maybe not everybody does, is Python's ability to scale down to problems on a small scale, where even though it's not a big data problem, human resources are the scarce resource. Okay, and at the end of the day, we had XML that looked like this, and turned it into XML that looked like that. Old, new, old, new. There you go. The next use case I had for this is where we work, we have an Oracle database, and there is a need to evolve the schema on our Oracle database. The tables in the Oracle database are not single application tables. Like many large databases, the database has value independent of the existence of any particular application. And so there's a need to periodically migrate the schema of that database. It's not like a Ruby on Rails project or a Django project where it's just part of the culture that you could blow the entire database away. This is a database that's been around for more than 10 years. So I was struggling. I spent a lot of time staring at SQL that would be updating tables. And I was looking for what can I do to help me with database migrations. I'm spending far too much time debugging SQL in my head, staring at code rather than running code. Because one of the problems with SQL that's manipulating tables in this way is it's not like a machine that you can run over and over again. It's more like a rocket that you fire once and it either gets to the moon or it blows up on the pad. And if it blows up on the pad, there's a big mess to clean up. And this is a very large database where rolling the database back is a non-trivial operation. You know, even the development database was almost a terabyte and only got refreshed every weekend. So if I try something and it blows up on the pad, I've got to clean up the mess by hand or wait till next Monday. So I was looking for something that would let me apply a change and then reverse that change. And I discovered that there were products that would do this. And one of these was Liquibase, which is a Java project, but you approach it from the command line. So the idea of Liquibase is it's this XML-based thing. And there's the concept of apply a change and reversing a change. And it does some very smart things like, well, what if I modify the text file after applying the change? How do we know how to reverse the change? And Liquibase does some clever things where it says, well, whenever you apply a change, we're going to record in the database itself that you applied the change and a hash of the change that you just applied. So that, and we'll check that against your file if you ask to reverse the change. And if the hashes don't match, we know that something's wrong and we're just going to stop. That's better than nothing. I mean, if it was my choice, what I would have done is record in the database how to reverse the change. But that's not the option they went with. For things like creating tables and creating indexes, how to reverse a change is obvious. You know, you just delete the table. For other operations, it's necessary to create a specific rollback segment in your piece of XML. That's great. This is giving me opportunity to run code rather than stare at code. I was wasting far too much time having staring contests with SQL. With this XML, I could run it. If I don't like it, roll it back, try something else, run it again. And I could have a file with a whole bunch of change sets in there, and I could say, run forward 3 steps, and it would go forward 3 steps. And the database would know what version it was at. And then I'd say, go back 2 steps, and it would go back 2 steps. You know, so this is awesome. And that's hideous. I hate that. I hate that XML. Hate it, hate it, hate it. I don't want that. I want, let's see if I've got some examples of this. Yeah, this is what I want. Why can't I have that? That also solves some issues where certain things, like when you create a table and you're granting privileges on that table, why should the granting of privileges be an entirely separate operation? Semantically, to me, when I create the table, I'd want the privileges to be right there with the create of the table. And this gave me the opportunity to do that. So it's like, okay, great. I've got YAML, so I can read things like this. I've got element tree, which lets me convert any data I want into XML, I can just define my own little language and have at it. And I don't even have to implement all of Liquibase, just that part of Liquibase I was using. Yeah, what I need is something that looks like a script that imports element tree and imports YAML. And yeah, here's just a little bit of boilerplate I'm going to stick at the top that's required. And I'm going to first just read the YAML into memory, forming this list of change sets. Because see, my topmost element was a list of lists where there's quite a bit of structure there, but the idea is to make it look beautiful to me, or readable, and then still have something that would be well parsable and understandable, both by YAML to get to like Python data structures, and then to my script to parse the data structures themselves and decide what to do. So borrowing from some sort of lispy ideas, it's like, well, the first element of any one of these things is going to be the verb, the name of the function I'm going to call. And then there will be some parameters passed to it, and then the rest of the data gets passed in. So there'll be some function that is going to called insert that's going to receive this, followed by all of that. And then rollback is a special case that goes to its own thing. So this goes on for quite some time. I mean, there's hundreds of lines of code here that I added a bit at a time to do these things. But at each step, it was fairly straightforward. So like add grant. Yeah, here we go. Is that then calls to make SQL, which is going to create a new element, an SQL element, and a rollback element. And then that's going to send those back to, it will append those to the change sets that I was already building. I'm not going to go into detail about how this works because your problems may be different. The point is, this is giving you the ability to author XML without having to write XML. That you can do things, inputs like this, that give you outputs like that. And solve nasty problems like, say I want to auto number. Well, this thing is auto numbering, and it's going to fill in the author for me. And any other kind of tedium like that you didn't feel that you needed to put in your input and is computable, you could have your Python code generate that for you. So you could come up with your own systems for doing things like this. And that's what I'd recommend you to do. It also solved another problem with Liquibase that I had. Remember I mentioned that if I have this file and I applied updates up to some point, or say past some point, and then I edit one of these sections that had already been applied, I'm not able to roll back anymore because the hash will not match what was stored in the database. By having this sort of two-phase system where there's the input file I'm writing and an intermediate XML file that's being delivered to Liquibase, that let me add additional automation in Python to cache those previous versions of the XML. So if I made the mistake of editing a block that I'd already applied, there was a way to go back. I just say, oh yeah, roll back, but use this previous version of the XML to roll back. And so I add a little bit more tooling, and eventually I'm in a position, because Liquibase could also dump a schema, where I could apply a whole bunch of changes, roll all of them back, and prove that I had gotten back to my original state. Because then I would compare a snapshot of the database schema to a previous snapshot of the schema. So there you go. I highly recommend that you look at YAML as a way of implementing little languages and as a way of avoiding XML of humans authoring XML. And that's all I have for you. Any questions? Which one?
PyYAML.
Mm-hmm.
You mentioned that of course, you can create a mapping or dictionary type. And is there a way of controlling what kind of object is created? You know, override the dictionary to maybe make it an ordered dictionary. Just substitute it that way.
OK, so the question is there a way to tell the YAML parser to use some other dictionary type if you have a dictionary, so that if you had an ordered dictionary? And the answer is, I don't know. I haven't tried to do that. YAML does have systems for customizing the types of the objects that are serialized, but that might require sort of altering the contents of your YAML document if you wanted to turn that feature on. You'd have to like mark it up and say, and this is some special thing. You know, an alternative might be to run it through a preprocessor, prefix your keys with like a 4-digit number or something like that that's incrementing, pull that into an unordered dictionary, and then reorder it. I mean, there are ways around it, but to do what you're wanting, I think would require modifying the YAML document itself with special markers saying, I'm using a custom type here. Yeah, I mean, changing the PyYAML code itself, that really amounts to like doing your own sort of pre-parsing. I mean, you could pre-process the file. You know, that's back to what I described as sort of my decorate the keys and then sort them later. I mean, it all amounts to the same thing. You're doing some kind of ugly thing to get what you want, either ugly in the YAML or ugly in some Python code somewhere. OK, was there another question over here?
I was just curious whether the YAML Liquibase stuff was online anyway.
It is not. I never got it to anywhere near a 1.0. I mean, I guess I could just throw it up on GitHub, but since then we've moved on to where we're not dealing with Oracle anymore. But
my point of view, one of the problems with a lot of the other migration tools is they're particular to a specific ORM or whatever. You can't use them across language.
yeah.
So that seems potentially attractive to me as something that you can use consistently, regardless of what language your application is written in. You can use a consistent database migration.
Yeah, I mean, it's not like the Ruby migrations or the Django migrations. This is agnostic database migrations. And I appreciated that, but then business needs changed, and I got out of the database migration game. So at this point, I just throw it up on GitHub and forget about it. But yeah, I do recognize that there is pain out there. You know, that pain that I'm not sharing anymore, but real, searing, shirt-ripping pain. And pray.
So,
yeah, and the problem with like dumb SQL runners like what Oracle provides is if there's an error, it just keeps running, compounding the error. Liquibase will stop on first error. OK, any other questions? Yes, yeah, the YAML language goes way beyond JSON to specify extended type information. I've never gone down that route, but there's a deep rabbit hole that I have not explored of marking things up in the YAML to tell how this data should deserialize.
the other thing to remember with YAML is you're effectively running arbitrary code, so treat it from that.
Yes, OK. Yes. Unlike JSON, YAML really has the possibility of being scary. I mean, much more than JSON, you should be very suspicious of YAML that's not from a trusted source. You had a question?
Yeah, you mentioned that the later versions of YAML were a
strict superset, yes. That's YAML 1.2.
Yes, and you said that that's the default YAML, and Python is not yet that version. Do you know
Right.
if they have a plan at what point they're going to roll that into Python or whatever?
I do not know. So PyYAML 3.10 is currently matched to YAML 1.1. With the Python standard library having a perfectly good JSON module that sort of takes the energy out of pushing PyYAML to 1.2. But I have not looked at the roadmap. I don't know where they are. It shouldn't be hard, but I don't know. Although there is a C component to it, a libyaml, so maybe that's holding it back. Yes? Well, I mean, Pickle, you're serializing to a binary format, a predictable binary format. YAML, you're serializing to text. YAML is all about the human. So you are trying to deliver or consume something where there is a reasonable expectation of a human being on the other side. Okay, I think we're done. Time to let the next guy